Image Isak. Onaka. There are few downsides to new observations, but confusion might be one of them. New stellar images bring mysteries that will take more time and effort to understand. That's offset by how freaking detailed scientists can start producing these pictures, and of course, scientists like hearing that there is more work to do. A team using the Very Large Telescope Interferometer VLTI at the Paranal Observatory in Chile captured this incredibly detailed image of the bright star Antares' surface. The image is probably the most detailed image of a star yet, more detailed than this. Yet the new observations brought uncertainty in the form of quickly moving gas clumps in Antares' atmosphere. Convection alone cannot explain the observed turbulent motions and atmospheric extension, the authors write in the paper, published last week in the journal Nature, suggesting the operation of a yet-to-be-identified process in the extended atmosphere. This image shows the velocity map of gas on the surface of Antares, where red is stuff moving away from us and blue is the stuff moving towards us. The black ring is a location for which data was unavailable. Image Isak. Onaka. Antares is the brightest star in the constellation Scorpius, a red supergiant only around 555 light-years away. It's around 883 times larger in radius than the Sun. If Antares were the star in our own solar system, it would engulf the orbit of Mars. The researchers observed the star's infrared light on 5 days in 2014 using 4 telescopes through a process called interferometry, taking data from multiple synchronized telescopes and combining the observations afterwards, turning them into one enormous telescope. Then, they reconstructed the image with a special analysis algorithm, artist's impression of the red supergiant star Antares. Image ESOM. Corn Messer. Aside from the detail, the researchers uncovered gases moving quickly, around 20 kilometers per second, far out into the star's surrounding atmosphere. But the team realized that convection, the process by which matter circulates by heating and cooling as in a boiling pot, couldn't account for just how far out the gas traveled, around 1.7 times the radius of the star. They noted that Betelgeuse, the star from which these astronomers stole the most detailed image title, has similar motion, but the gas only moves a quarter as quickly. The next challenge remains to identify the driving mechanism responsible for the observed turbulent motions, the authors write. Others thought this was an interesting piece of work. The most intriguing part of the new observation is that it unveils the remarkable complexity of physical processes that take place in the atmospheres of such stars. Maria Bergman, astronomer at the Max Planck Institute for Astronomy in Germany, told Gizmodo. This motivates better models which can be used to infer more accurate information about the life cycles of these stars, thus making interesting predictions for how the stars live and when they die. As with all studies, this one has limitations. Bergman explained that modeling stars like Antares that pulse irregularly is difficult. Additionally, these observations were taken solely in the infrared wavelengths, so some of the information wasn't present in the image. The findings by Onaka et al. Remain to be confirmed by observations at optical wavelengths, she said, where titanium oxide TO opacity is an excellent diagnostic of the conditions in the stellar atmosphere, but, as always, with new data comes new mysteries. There are a crapload of things we simply don't know about this universe we live in. Nature. This article has been updated to include a quote from Maria Bergman.